And I've got a little bit more to talk about in terms of universe self-replication cosmology. I thought I'd give a little tutorial to explain it in a simple term. So, kind of eyeball this. This is a flat plane which has something squeezing down on it. The flat plane is supposed to represent the three-dimensional universe, broken down to 2 dimensions, and it's called an embedding diagram. And there's something that's pushing down on it like it's a rubber sheet, makes a depression. That's what is representing gravity. Any particle that pushes on that plane kind of stretches and distorts space itself. Okay, so let's say that we have a little particle that we're going to use to create a new universe, and that's what's making that depression in the middle of the space-time in the parent mama universe. How do you turn it into a new universe? It has to be a quantum tunneling effect, starting with a strange form of space, matter, or force. We actually don't know. Physicists don't know what it is for sure. But whatever it is, it's a object that has negative pressure. So we're going to try to drill down into that and how that can create a new universe. Something with negative pressure isn't intuitive, but if you think about quantum weirdness, negative pressure is a sucking, opposite of pushing out. You know, something that has pressure is trying to expand, make a balloon get bigger. This is something that if you put it in the balloon, it would suck it down to nothing. So how's that going to make a new universe? Well, you have to think of more quantum weirdness. You got this sucking, which makes it get smaller and smaller, but in the quantum fluctuation world, it can go right past tiny and start spreading out again. So it makes a sucking beyond zero, and that becomes a spreading out. And that's this teardrop at the bottom here. It's quantum tunneled into where it's spreading out, and the spreading out has separated it from the parent universe because it's just, nonsensical for the as you look at it from the parent universe. It's sucked past nothing. How can you suck past nothing? Well, that's what it does. It tunnels out of the universe. So now you got this thing, and I said it had negative pressure that has started a new little thing in the vacuum, the wider realm beyond individual universes. Why doesn't it just suck itself into nothing and go away again? Well, first of all, you got to realize that now it's sitting there all by itself. It's got nothing to suck on. It's just kind of hanging out on its own. And here's where it has to have inherited Einstein's law of physics, Einstein's general relativity, and we got to kind of invoke a little bit of math here, because if you break down Einstein's general relativity, which has been, obviously really well demonstrated in many different observations, into what's called Ricci tensor, R-I-C-C-I, and that sort of helps describe the physical effects described by the equation. One term in the Ricci tensor describes the gravitational force caused by pressure. And in our real world, pressure is so tiny that it hardly has any impact on the real gravitational force of, like the atmosphere with its pressure. But this little particle has a massive pressure, and it's negative. And it doesn't have a whole lot of mass of energy, at least relative. Well, let's just say it has energy and it has negative pressure. So, as it turns out, in this Ricci tensor term, the negative pressure is 3 times, or any pressure in any state, is 3 times more gravitationally powerful than the mass or the energy density. So, in this tiny little particle with negative pressure, the negative 3 times its positive energy makes it have a net negative gravitational attraction. So it's a gravitational repulsion. And it's the same thing that dark energy is. So it's another thing, dark energy is another thing that's in the same class that would create universes that we call inflation. Nobody really knows what it is yet. There's another term called quintessence, which is trying to unify all these things. Inflation and dark energy. But this little initial particle, a little bead, teardrop, has negative gravitational force, and that makes it just explode into a big bang. It just keeps expanding and expanding against nothing because it has a gravitational repulsion, and the only way to make it stop expanding is for it to change a phase, so to speak, into a different state where it loses its negative pressure, or the negative pressure. And again, it's like we don't know how this change happens or even what is changing. But essentially it has to be a state where the negative pressure and gravitational repulsion gets reduced or gets under control. Dark energy also has this negative pressure, and yet it's not causing the extreme expansion that happened at the beginning of our universe, as we can observe from all the various things like the cosmic microwave background. Anyhow, I've tried to give you a kind of a simple and intuitive explanation for how mama universes can create baby universes, and it depends on this strange state of matter that it only existed in the early universe, but may be related to what we see now in dark energy, and may be the same thing. And we've still got work to do to figure out exactly what all that is. Science is an ongoing effort. Okay, that's all for now. We'll talk to you later. Bye-bye. Okay, video number 2. I thought I might not have a 2 today, but I've just given in the tutorial and tried to explain how Mama Universe can create a baby universe by creating a little particle that has false vacuum, whatever that is, and it tunnels into its own space where that false vacuum with negative pressure, meaning negative gravitational force, just expands and goes crazy. So that's how a parent universe might give birth to a child universe, but it still begs the question, where'd the parent universe come from? And it's not turtles all the way down, as they say. You can't, well, let's put it this way. That's what's called infinite regress. What goes back forever and never has an original source, but gets lost in an infinite stack of turtles. I'm not a fan of that. And it doesn't explain anything. You know, what's holding up the last turtle at the bottom of the pile. So my philosophy on this, and I don't know whether I've made it clear where I'm trying to go with this here. we've talked about how the mama universe creates a baby universe, but what created the first universe? What created what they call a universe from nothing? Or is there, does it just have to say, some people will say, well, it's just a brute fact that there's a universe. Or that it's a brute fact that whatever was back there does go back infinitely and is eternal. I have another answer, or a different answer, and I talked some yesterday about what is sort of beyond the beginning of the universe, and you can't say back in time because time didn't occur until the universe got created, and neither did space. So this stuff that I've talked about, that's essentially the real vacuum, which we can only interrogate within our laws of physics and see that it makes quantum foam and stuff like that. Our observations of it show that quantum stuff is very important. How does this stuff that was there before the universe cause a universe or allow a universe to happen? Well, first of all, this stuff isn't actually fully real. It's virtual, and it creates stuff, or it can, its potential is to create stuff that is actual, and that's a different term from real, and maybe there isn't really a real, because this parent stuff is definitely not real. But within that parent stuff, you can just assume, or you can just imagine that anything can happen, and also that there are no laws. It doesn't have a rule that says anything can't happen. If it doesn't happen, it's just not even in the discussion, so to speak. It's just, you can't make 1 + 1 = 3. Well, you can, and I'm going to talk a little bit about that today and sort of like debunk the power of math, and yet not, because math is really important. But so in this shadowy state, in between being real or being actual and not existing, there is the quantum foam. There is virtual particles that come in and out of existence in a real quick period of time, less than what's called the Planck time, which is a time that you can't actually observe anything that doesn't last longer than the Planck time, to put it in real simple terms. You have particles that are like an electron and a positron, the anti-electron. They appear out of nothing, literally, or out of this vacuum state, and then they disappear within a quantum Planck time. So how our universe began, my hypothesis, is, let's look at the teardrop part of this picture and imagine there's nothing above it. What popped into existence, as I discussed in terms of how the baby universe got started, a sucking particle, a particle with negative pressure, but it needs to have a partner. And coming out of the emptiness of this strange state called the vacuum, particle pairs occur, and then they recombine and disappear. So the sucking, the negative pressure, has a partner, which is a positive pressure, a balloon. So you have a balloon and an anti-balloon. And the way we got our universe started, and this is of course my own sort of idea, philosophy, theory, is that this balloon stuff, which may be quintessence, may be an inflaton, the inflation, or it may be a manifestation of dark energy, or something that combines all of that, the balloon particle quantum tunnels and starts this baby universe creation process. And its partner, the real balloon, not the this is the anti-balloon. The real balloon has positive pressure and positive mass. It has gravitational attraction for itself, and it just vanishes because it collapses back into a crunch. Its gravitational pull on itself just puts it back into nothingness. You know, a tiny dot that just no longer can support itself. Yeah, so that's how we get our universe from nothing, using the same mechanism that initiated baby universes. And so it's pretty fundamental if that's true, and that's why I like this philosophy. It is the same for both the creation of baby universes from our existing universe and the creation of the first ancestor universe from quote-unquote nothing. And the philosophy of what is nothing and why there is nothing rather than something is one of the deepest subjects there are. And my take on it is nothing is an absolute, so it's not even really in the equation. It's not even worth discussing. And I'm going to talk a little bit more about absolutes in terms of math in a second. But nothing has to be in a superposition with something. There is no such thing as either something or nothing, which is why the question, why is there something rather than nothing, is just not the right question. Anything that is a practical, actual nothing coexists in some kind of a philosophical space with the something. And that'll be where I stop for now, and we'll do the math tutorial, and then that's it. Well, okay, here's the math part of today. I have kind of a love-hate relationship with math. Math works in the world of the abstract, and it crosses over into, people call it absolutes. People say there is, math is fundamental. And my personal philosophical position is there is no absolute. Nothing that is absolute has any relevance to our physical, real world, which is contingent and finite. So, let's just talk about 1 + 1 = 2. Probably math that most of us can understand. So I have here 2 sticks. Do I? I wish, okay. One of them is this stick, and one of them is this stick. How do you define stick? Let's say that I have 2 friends and they both want a stick, and I want to keep mine. All I have to do is break off this branch of this stick, and suddenly I have 3 sticks. And whereas I had 2 before. 1 + 1 = 2. Well, you break it off, and then all of a sudden 1 + 1 = 3. Because the absolute of math says nothing about 1 + 1 being one particular physical object. And how do you define the particular physical object? You can't take the abstract into the physical world and have it make any sense, because every physical object is subject to a definition. So what is a stick? Let's say that my 3 friends come along and they each have a friend of their own. They can break their stick in half, and then now we've got 6 people with sticks, and we started with 2 sticks. 1 stick plus 1 stick equals 6. Math gets, has extremely useful applications in the real world, but it requires very strict rules. How you define sticks, how you define whether you can break sticks up or whether you can't, things like that. And when you get to infinities, the world of mystical world of the number infinity, if you can even call it a number, things even get more weird. Now, when I was in 8th grade, I was sitting in the library during a study hall period when I had nothing to do and no work to do, and I started contemplating infinity, and I imagined myself holding a string, and I had the end of the string in my hand, and there was no other end to the string. So, like in this discussion we're having here, I could say I could cut off a piece of the string, give it to my friend, and now I have 2 pieces of string, one of them being infinite, and the other one being a finite piece. The one that's infinite, as I understood it in 8th grade and still am perfectly comfortable with now, is that effectively that other end of the string, if you can even define it as an end, simply exists in that abstract, no, not abstract, in that virtual space that is a superposition of existing and not existing, of being definable and not being definable. Mathematicians come up with these weird things called countable infinities. The set of natural number of integers is supposedly a countable infinity. But dude, you can't count to infinity. I'm not going to dwell on this too much, but there's another thought experiment similar to the piece of string and cutting off ends of it and giving all the pieces you want to friends, and it's called the Hilbert's Grand Hotel paradox or conundrum, in which you have a hotel with an infinite number of rooms and every room is occupied. And Hilbert claims, the way he defines things and the way he does the math, you can always make room for another guest in that hotel, even though all the rooms are full. And the way he says you can do that is you can take every guest and you can say, you move out of your room and move into the next room. And that leaves this first room open for a new guest to move into. But wait a minute. Which part of every room is occupied did you not get, Mr. Hilbert? It totally depends on how you define it. Apparently what Hilbert is saying is that the number of rooms is the number of guests and the number of rooms are not the same number, and the number of rooms can be turned into the number of guests plus 1, and therefore you have an empty room. They're both infinite numbers, so you can play with it. It's all definition and garbage and abstract, and it may have applications in our real physical world, but you can't. Mathematics can't automatically translate into real physical world. There's another thing that really bugs me, and I'm going to end with this because it's going to get to be too long of a video. But Hilbert was also really big on the law of the excluded middle, which basically is a simple argument that says every proposition, everything, every mathematical object has exactly two, every simple mathematical object, let's say, has exactly two states or two descriptions. It's either true or it's false. There's nothing in between. And it's a really important axiom for math, or maybe axiom isn't even the right word, but for a lot of math to work, you need that simple, ridiculously absurd law that says you can't have something that's partway between true and false. In the real world, pretty much everything is like that. You know, define a stick. Is it a stick or is it two sticks? Well, it's both, and it depends. And that's the it depends is what mathematics just, you can't handle very well. So, yeah, that's just my, every mathematical law has its rules, has its applications, but they aren't absolute. And I think I've talked before about Gödel's incompleteness theorem, which basically demonstrates that in the pure world of math, any mathematical system that you develop ultimately doesn't apply to everything, and particularly can't prove its own validity. Either it is incomplete or it makes statements that it can't validate, like its own absolute validity. So math, like everything else in the real world, is rooted in paradox. And that's my bottom line. This paradox, which I call in the physical realm the vacuum, the space outside. And it's not even really right to say the word outside, but from a sort of a God's eye view, outside of our universe. It doesn't truly exist, only virtually can be talked about. And the far end of the string, that's an infinite string, virtually exists. These are all concepts that math has a hard time properly nailing down. And in almost every case, every mathematical formulation, we have developed sort of an esoteric thing called Zermelo-Fraenkel set theory, which is sort of like considered the foundational root of all math in the modern era. And it replaced things that had paradoxes in them, which is now called naive set theory. And it's not naive, it's practical. It's what, natural language is comfortable with. Something that is a set is a group of things, but then you have to worry about Russell's paradox, the set of all sets that don't contain themselves. And your brain just goes through the roof trying to figure that one out. It's those kind of paradoxes that math can't deal with, and so essentially just ignore them and find a way around them and say, well, not everything can be considered a set, but in the real world, that's not common sense. Okay, I will ramble on and on if I don't shut up. That's my little math tutorial or philosophical stance there on math. All right, that's all for that. Thank you. Take care. Bye-bye.